Hi, in this video we will go over how transcription works in prokaryotes. First, we have transcription initiation. Let's start here at the DNA. This region is the promoter. In prokaryotes, transcription begins when the RNA polymerase binds to this promoter. But RNA polymerase doesn't act alone. It first combines with a protein called the sigma factor. Together they form the RNA polymerase holoenzyme. Now, this holoenzyme binds to the promoter and forms what's called a closed complex. At this stage, the DNA is still double-stranded. Next, energy stored in this complex is used to separate the DNA strands. This creates a small open region called the transcription bubble. Now the template strand is exposed. At this point, transcription begins. RNA polymerase starts synthesizing RNA by adding nucleotides complementary to the DNA template.
Now I'll be talking about transcription elongation. Once RNA polymerase successfully starts making RNA and moves away from the promoter, we enter the elongation phase. As it moves along the DNA, the RNA strand gets longer. This is called elongation. During this stage, an important change happens. The sigma factor, sigma 70, detaches from the RNA polymerase. It is no longer needed once transcription is underway. In its place, another protein, called protein NUSA, binds to the core RNA polymerase. NUSA helps regulate elongation and prepares the system for proper termination.
Now let's look at transcription termination. First, the row-independent termination requires a sequence at the end of the gene that has a GC-rich palindromic region, followed by a stretch of uracils in the RNA. The GC-rich region folds back into itself to form a hairpin structure in the RNA. This hairpin typically disrupts the interactions between the RNA and the DNA template. At the same time, the DNA and RNA hybrid contains many AU base pairs, which are relatively weak. The combination of the hairpin structure and these weak AU interactions cause the RNA to detach from the DNA and RNA polymerase. This releases the newly synthesized mRNA. Another mechanism for termination is row-dependent termination. Here, a protein called Rho helicase is involved. Rho binds to a specific site on the RNA called the rod site, near the 5' end of the newly synthesized RNA. Using energy from ATP hydrolysis, Rho moves along the RNA towards the RNA polymerase. Eventually, Rho catches up to the RNA polymerase, and when it does, it uses its helicase activity to separate the RNA from the DNA template. This releases the mRNA and ends transcription.